Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the already proven differentiation rules in computing the derivative of this given rational function. So we have here another rational function and we are tasked to give its derivative using the already proven differentiation rule or rule on differentiating rational functions or quotient of functions. Take note, we have here our function identified as 6x cubed minus 2x all over 4 minus 5x. Clearly, this is an example of a rational function, and we can identify using the idea of the rational function where if this is f of x and f of x is a combination of k of x. I'm just using other variables to make sure that this is not confusing with the already proven rules where m of x is not equal to 0. Our k of x here is 6x cubed minus 2x, while our m of x is denominator 4 minus 5x. Okay, we are looking into this because the rule on differentiating rational function, if we are to get its first derivative, which is also considered as a quotient of functions, we are going to follow this rule where we copy the denominator m of x, multiply the first derivative of our numerator minus our numerator times the first derivative of our denominator. Take note, the operation is subtraction, and subtraction is not commutative, so we can't interchange them. This is all over the square of whatever function on our denominator. So once we have identified this, we can simply take first, using our scratch paper, the derivative of k of x and m of x before we could apply the rule on solving for the derivative of that, or yes, the first derivative. So for k of x, this is we have the difference of two functions, 6x cubed and 2x, or again, we can use the idea of sum. We're going to use here the rule on differentiating sum of functions. We'll have 6x cubed, right? So we copy 6 and then we use the power law for this. So because this is a constant multiple, x 3 minus 1. Sorry, I forgot to write the exponent. Let me move this here. K prime of x is 6 times your n, xn minus 1, or your 3 minus 1, sorry. That's the 3 minus 1, minus 2 times x1 minus 1, which will give us 18 x squared minus 2, as this is x to the power of 0 all equal to 1 times 1, so it's just 2. Hopefully that's clear. And then as we go to m prime of x, similar thing, we have a binomial expression. So the first derivative of 4, which is a constant, is 0, minus 5 times x1 minus 1, which will give us a result of negative 5, because this is x again to the power of 0, that's equal to 1, so it's just negative 5. With all of this already identified, let us proceed now to our derivative of this rational function following this rule here, where first we copy our denominator 4 minus 5x times the derivative of our denominator here. You have 18 x squared minus 2. Sorry, minus 2. Minus, you copy our numerator 6x cubed minus 2x times the derivative of our denominator negative 5. Sorry for that. Let me use the spaces later. But before we proceed to that, let's complete here. We take the square of our denominator. By the way, if you have this type of expression for your denominator, if it doesn't necessarily be or help in simplifying the entire function, you may stick to that. But for some, they tend to combine this or simplify this form if there are chances for our numerator to be simplified as well. But in this case, let's stick to that and let's move down here. So we will have f prime of x again, a little bit lower, still lower, so that I could really see the form, because your your numerator here has two binomials. This is for the first term, so you're going to apply the FOIL method. So please review your FOIL method. You have the first term, so 4 times 18 is 72. Let's check. That's 36 times, yes, so that's 72. X squared. Outer, you will have minus 8. Inner, you will have your minus 5 times 18. You have 50 plus 40. So you have 90x cubed. And your last terms plus 10x. I'm doing the FOIL method for this area alone. Then, for the next here, you can simply combine negative times 6x cubed. So negative 6x cubed times negative 5. So plus 30x cubed. Again, that's 6 times 5 or negative 5, negative 30. But since you have a negative sign here, so that's positive 30. Then, negative times negative 2x, that's positive 2x. Times negative 5, so you'll have a minus 10x. Okay? All over again, you may stick to this for minus 5x the square of that. Okay? So as we move further, simply simplify all the necessary terms. You may just simply remove this grouping symbol because it was preceded by a positive sign. Combine all necessary things. Let's start with x cubed, arranging the terms into descending order of exponents. You have negative 90 plus 30, so you have negative 60 x cubed. For x squared, you only have 1, so plus 72x squared. You'll have here plus and minus 10, that's 0, so minus 8 all over this form. So again, you may, of course, simplify this because this is just 4 minus 5x times 4 minus 5x. If you can look for possibilities of simplifying this numerator, yes, you may. I believe this is final answer for this. So we apply here the rule in differentiating a quotient or for rational functions using this idea and this identified functions here. So please try to review if my answer is correct or not. Thank you very much for watching. So what are you waiting for? Subscribe now.